Okay, so welcome for this session dedicated to the design and of retaining structures and anchors. So it will be made of 4 presentations, so brief presentation about clauses 7 and 8 that are really related to retaining structures and anchors, plus a short presentation of the Annex D where you can find different calculation models in line with the design of retaining structures and gravity walls. After, there will be an academic example presented by Sebastien here. After, the results of the benchmark that will be presented by Loretta, and to finish we will have a presentation from Gilles about a case study. It has been prepared by Thomas and Gilles, but Thomas is not here because his wife had just had a baby, so he has better things to do, if I can say that. Okay, and we have more or less 1 hour and a half to cover all these subjects with questions and discussion. So the idea is maybe to have questions just after each presentation, and after, as the presentations are not so long, it will be possible to have a general session of discussion at the end. The content of clause 7 and clause 8 is about retaining structures and anchors, so it covers in a way a very large range of structures. Since you can have, for example, some metro station, as you can see, it can be used for maritime infrastructure, as you can see there, or it can be used, as you can see there, for gravity walls, so for maybe a simpler or geotechnical structure, or here with a big retaining wall, as you can see there in Monaco, for example. So the design of these structures refers to different parts of Eurocode. So first of all, of course, Eurocode 7 part 1 and part 2 regarding the GIR and the GDR, as it has been described this morning. There is the question of groundwater level, so it will be addressed, I think, by you, Adrian, not in this room, in the amphitheater, just after the coffee break. It refers after to numerical models. Our finite element methods is more and more used to design all these structures, especially huge retaining walls or huge deep excavations. The interaction with the other Eurocodes is also ensured regarding Eurocode 0 for the design principles, the actions, especially, for example, for maritime infrastructure, as it has been said by Jean-Bernard this morning, when you have waves, river, you can have some of the actions from both waves and rivers, and after you have the structural verification, depending on the type of material that you can find, so concrete for diaphragm walls, steel for sheet pile walls. You can have also timber and masonry if you have some geotechnical structure like that. After, inside Eurocode 7 part 3, these 2 clauses are in interaction with many other clauses. Maybe it's not the case, for example, when you read shallow foundation or when you read the deep foundations, the interaction with the other clauses are not maybe so important, but here you have to refer, of course, to clause 4 in order to check the overall stability. When you design a gravity wall, you have to refer to clause 5 in order to verify the external stability of your wall, considering the sliding verification, the bearing capacity verification, and in some conditions where you have a wall on piles, or when you have, for example, a diaphragm wall that is submitted to huge vertical loads, you have to refer to clause 6 in order to verify the bearing capacity of the diaphragm wall, for example. And at the end, as for these structures, you have to manage the water, you can refer to clause 13 about the groundwater control measures. So we can see that clause 7 and clause 8, in fact, are really in interaction with many parts, with many other clauses of Eurocode 7 part 3. So in details, what we can find, so it's very, I think, difficult to give you an exhaustive overview of the content of clause 7 clauses 7 and 8. So regarding retaining structure, what is, I think, is important in the code, so we can say that everything is important in the code, but maybe what is the most important is the list of ULS that can I say, it can be something important for the designer in order to not to forget what the limit state to verify. So of course overall stability, rotational resistance, break resistance, sliding resistance, resistance to basal heave in excavation, the supporting elements, so especially anchors, and after the structural resistance of your sheet pile wall or your diaphragm wall. So this is what you can find for retaining structures. And regarding anchors, there are two main verifications, one for geotechnical resistance and one for structural resistance. Of course, if you have some struts, it's not directly covered by the code because it only refers to the structural resistance of the strut, and so you can directly go to Eurocode 3 part 5. So regarding the retaining structures, so there are many aspects to consider for your design. Maybe the most important, so what we have kept from the old Eurocode 7 is the uncertainties about the wall height h that we have to consider. So depending if we know or not, or if you have some uncertainties considering the depth of the excavation, we can vary this height with this parameter. After, of course, there is the groundwater level, groundwater flow, dewatering system, so it will be completely addressed by Adrian in the next session. There is, in some conditions, the environmental effects that are described, so the temperature, for example, for the strut, the effect of frost for gravity walls, or the effect of swelling, both maybe for gravity wall or the swelling that we can have at the base of the deep excavation. After we have, as for any clause in Eurocode 7 part 3, you have a table with the depth of the ground investigation. So this table is a national determined parameter, so it can be changed in each country depending on your own practice. So it's always a difficult subject to address what is really what should be or shall be the content of the ground investigation. But you can find this table. It's the first try in order to define something. After some points that are important, but I will not address in this presentation. So the bearing resistance and the vertical equilibrium. So it refers to clause 6, but you have some indications in clause 7 about the fact that you have to consider the vertical equilibrium into your design. And after you have some information about the monitoring and the interaction with the observational method. So maybe what is the most important thing in this clause is this table where you can find the different approaches that have been selected for the design of retaining structures. So here, in fact, we can proceed as we want. In fact, we are, for example, if you focus on pile, there is a clear approach with VC1 and resistance factor approach. For shallow foundations, the number of approaches that we have in Europe are, I think, are similar, so it has been possible to harmonize the practice. But for retaining structures, we have, in fact, two complete different points of view. There is if we start with the resistance factor approach, so you have the resistance factor approach, which is combined with the verification case through. So in fact, it refers, if we use the old Eurocode 7, to the DA2 star. So you can make a calculation with representative values, and at the end of the calculation, it's possible, for example, to calculate a kind of safety factor by making the ratio of the passive pressure to the mobilizer's pressure, or the effect of actions are obtained by applying the partial factors on the representative value. So there is this way of calculating that is written, or we can proceed to the old DA3 or the geotechnical combination of DA1, where you combine a material factor approach and the verification case 3. So with the verification case 3, there is no partial factors that are applied on the actions. So not on the accent, not on the active or passive earth pressure, and you apply the partial factors directly on the shear strength properties. So basically, in fact, this type, the combination of VC3 plus MFA, when you calculate huge excavation, you proceed to shear strength reduction procedure, which is now a very common approach in many software. After maybe a clause that are, how can I say, provided many discussion is when you have to analyze the interaction between the rectangling structures, and you have to analyze the overall stability, or how the deformation due to the verification of overall stability can influence the bending moment or the shear forces into the action. So this clause is, I think, important for the design, and so you can have several ways to follow. So you can proceed directly to for example, shear strength reduction. It's what it is written here. The effects of action on the rectangle wall are checked using a continuum numerical model. You can check the overall stability by considering a failure mechanism that goes through the retaining wall, or you can also check overall stability by considering only failure mechanisms that go below the retaining wall. And in this case, in order to ensure enough safety, the code recommends to apply an additional model factor to have enough safety when you calculate this failure mechanism. So I think regarding the design of retaining wall, this is what you can say. After, in the annex, I will come back on different issues. So regarding the anchors, maybe the most important aspect is, again, the distinction between VC1 and VC3 and VC4. So with VC1 and VC3, it's possible, especially with VC3, we have directly the design value of the action, for example, into the anchors, and so we apply just a partial factor outside, while using VC4, so the old DA2 star, we calculate the representative value of in the anchor, and so we need to apply a first partial factor on this representative value, and a second, if necessary, depending on the national practice. So this is, I think, a very important clause when you make the calculation of anchors. Regarding the anchors, after, what we can highlight is the existence of these different tables that are in line in a way with the test method that we use in order to check or to control the tensile capacity of each anchors. So you have two test methods, and depending on the two test methods, you have different partial factors that can be used, and after, each test method is linked to, can I say, a creep parameter that can differ from the method 1 to the method 3. So again, the idea of this table, they are open to national choices, but the idea of this table is to present to the designer the different ways of designing the anchors across Europe. After, it's maybe important to finish the presentation to quickly describe the content of the Annex D. So what we can find in Annex D, so you can find the relationships in order to calculate the active and passive earth pressure. So the question of the stress inclination, in fact, it is addressed into the main text. So you have some recommendation in order to limit or not the stress inclination. So in general, the stress inclination is limited to 2/3 of the friction angle phi, but you can have greater inclination. In Annex D, you will find the description of different models that can be used according to the content of Eurocode 7. So Eurocode 7, for the design of retaining walls, do not, can I say, recommend a precise calculation model. you can proceed to a limit equilibrium, which is in general the case for gravity walls. And after, regarding maybe deep excavation, when you have diaphragm walls or sheet pile wall, you can use beam on springs, or you can use finite element method. So the idea is to let the designer select the calculation model that he considers as the most appropriate for the situation he has to design. After, in this annex, you have several indications on the way to assess or to determine the earth pressure coefficient at rest key node. You have some calculation models in order to verify the basal heave. You have some recommendation about integral bridges, how you have to calculate the passive earth pressure for integral bridges. So integral bridges are bridges that are completely connected to the pile, so thermal variations induce a lot of additional axial forces into the span, and so it depends a lot on the passive earth pressure that you can have between the two extremities, the two edges. After, you have some information about compaction effects, intermediate pressure, some information about the vertical wall stability, and the current verification. After, in detail, so we have spent a lot of time in order to precisely calculate the different coefficients, because these coefficients have been determined, I think, 80 years ago, so sometimes it's difficult to identify the clear relationship, but here it's important to say that the annex describes these three coefficients, so in weighted ground condition, for weightless condition, and the effect of cohesion. For weightless ground condition, so we have presented the exact solution. So if you use this solution, the calculation is exact. After, for the cohesion effect, you can use this solution, and again, this is the exact solution. And for weighted ground condition, you can use this approximation, so it's possible to calculate the earth pressure coefficient for active or passive states based on this approximation, or you can directly use the Kakok result chart. After, another subject that has been discussed with our colleague from Eurocode 8, especially Sebastiano, and I don't remember Luigi Callisto, is to, and I think it's a good thing, is to ensure the full compatibility of this coefficient with the Eurocode 8 part 5. So you can proceed to a rotation of the model, or in the Eurocode 8 part 5, you have direct relationship in order to calculate the active and passive earth pressure in seismic condition, but that are completely compatible with this rotation of the model. So what we can say in conclusion about these two clauses that are it's very difficult in 10 minutes or 15 minutes to describe the different interaction, but what we can say is that many types of retaining structures can be addressed. So for very simple gravity walls to a metro station with different level of slab, of anchors, or for struts. The interaction with anchors, as it was the case for the old Eurocode 7, is completely addressed. So one section for retaining wall, another section for anchors. As I have tried to present, many issues are really covered in addition to the old Eurocode 7, so the way to calculate the earth pressure coefficient at stress, the verification of basal heaves, the Kranz verification. So we have a very complete code in order to address the different issues that are necessary to design a retaining wall. The calculation models and methods are also described, so which is, I think, nice for especially young engineers. And after, all the interaction with the other part of Eurocode 7 are ensured. So thank you for your attention. And